Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey, everybody. Welcome to Wednesday Night Math Night. As he said, I'm Amy Sink, and I am one of the math specialists here at the Learning Liaisons, and I'm so excited to spend my Wednesday night with you. Before we get started, I always like to start off with a little bit of introduction because it helps me kind of guide the conversation and where we're going and all of that. So if in the comments you can comment and let me know where you're from, what test you're prepping for, and if you could play any sport, what would it be? Like if you had unlimited ability, what sport would you play? I like to watch baseball, but if I could play any sport, I think it would be gymnastics. I'm not very agile. I was a dancer growing up, but I don't have that tumbling ability, but I think that would be really cool. So in the comments, let me know where you're from, what test you're prepping for, and what sport would you play if you had all the ability in the world. As we go through the problems tonight, I want you to pay attention to not if this problem is appropriate for me or not, but what pieces of this problem are appropriate for what I'm studying for. I try to make sure that every problem has at least one element that's good for everybody in this room, because not all of the questions are going to be appropriate for everybody because we're all taking different exams, K through 12. So I like to make sure I at least have one element that is great for everybody that is here tonight. So, one more thing. As we go through these problems, if you find that I'm not going over exactly what you would like to see, let me know in the comments. If you're like, I really need more help with geometry, or I really need more help with circle problems, or binomial expansion, or whatever, let me know in the comments. A lot of the problems we're going to go over tonight are from many of you sending me messages on Facebook or tagging me in a post or tagging me in our customer group. So let me know what you want to see from me in the future weeks because it helps me guide the conversation for you. So I see a lot of people would like to play soccer. We've got Praxis 5169. Hey, Gary, math 7 through 12. Hi, Rosanna, volleyball, awesome. Hey, Shannon. Hi, Megan. Hi, Wendy. And thank you for the belated birthday, love. I really appreciate it. Hi, Brittany. We've got a packed house tonight. So the first problem we are going to go over is what I like to call famous GK problem. This problem is seen on the FTCE website, but this is appropriate for anyone taking an exam that ranges from 4th through 12th grade, which is really everybody. That ranges for everybody. So the barn problem, the infamous barn problem. So this problem is in our GK course, but this exact problem. However, unfortunately, when I solved it incorrectly. So I'm going to solve it for us tonight. And then I'm in the process of re-recording it and getting it over to our video editing team. But I wanted you guys to be able to see how to solve it. However, even if you're not taking the GK, if you are taking a middle school, high school, Praxis core exam, this is a problem that you need to know how to do. And I'll talk you through that in a minute. So a farmer needs to compute the volume of his barn for storage purposes. The barn has a rectangular base measuring 14 feet by 20 yards. It is 5 3/4 feet tall on 2 sides and is 18 feet tall from the base to the peak. What is the volume of the barn? So before we get started, let's define what volume is of a prism. Because all this is, yes, it's a barn, but it is a prism. How do I know it's a prism? I'll explain that in a minute. Volume of a prism is area of the base times the height of the shape, where the big B is the area of the base. Now, in order to calculate the area of the base, we have to know what the base is. One of the most common mistakes on this problem is people assume that the base is this rectangle right here, and they multiply 14 times 20 or 14 times 60. That is not the base of this barn. The base of this barn is actually this pentagon right here. Now, this doesn't make sense for our common sense human brains, because we think of a base as the part that the shape is sitting on. And a barn is sitting on the ground down on that rectangle. However, the base defined in a prism is 2 identical shapes that then have rectangles surrounding, connecting those 2 shapes. So we notice we have 2 identical pentagons here. And then around the shape, we've got rectangles connecting those pentagons, which is why those pentagons are the base. If you ask me why are the pentagons the base, the reason is because of the definition of a pentagon, okay? So, or the definition of a prism, I'm sorry. The prism is defined by 2 identical bases with rectangles surrounding it. This rectangle on the bottom does not have a matching rectangle, which is why that's not the base. So in order to find the volume of this shape, we have to find the area of the pentagon. Big B equals the area of the pentagon. To find the area of the pentagon, what do I need to do? Well, in this case, this is not a regular pentagon, so we need to cut this pentagon into 2 different shapes, a rectangle and a triangle. Find the area of the rectangle, find the area of the triangle, add the 2 together, and then we get big B. So let's go ahead and find the area of the triangle part of this pentagon. So if I cut this pentagon into a triangle and a rectangle, I know area of a triangle equals 1/2 base times height. My base is pretty straightforward. I know that this is 14, so my base of my triangle is going to be 14. So 1/2, 14. Now, what is the height of this triangle? That's one of the other places where people make the most common mistake. The height of this triangle is this piece right here. but it only hits at that base. So it's not 18 because 18 is the height of this entire thing. So how am I going to find just this much of my height? That's the missing piece. Well, think about what other information we've given. We've been given that this is 5 3/4, which means that this piece is also 5 3/4. So the height of this triangle is 18 minus 5 3/4. Louisa, excellent job. And you've beat me to the conversion. So I'm not there yet, but yes, I am going to have to do that. So I'm going to multiply this times 18 minus 5 3/4. And I don't have my phone, which I usually use as my calculator. It's somewhere in the back. So I'm going to subtract on my computer calculator. 18 minus 5 3/4 equals 12.25. So 1/2 times 14 times 12.25, all of that equals 85.75. Now, I just did all of that work, and all I have is the area of the triangle of the base of the prism. Let's find the area of the rectangle. Now, for those of you who have our GK course, this is where I failed. I neglected to find the area of this rectangle down here. Are you looking for my phone? Oh, you're getting the bottom. So area of a rectangle equals length times width. Area of this rectangle is going to be 14 times 5.75. And so when I calculate that inside of my handy dandy calculator, buddy, it's on top of the coffee maker. It's on top of the coffee maker. Sorry, my nephew's making a bottle for my son. So 14 times 5.75, that gives me 80.5. That's only the area of the rectangle. So now I'm going to add the area of the triangle, which is 85.75, to the area of the rectangle, which is 80.5. And that gives me 85.75, 166.25. That is the area of the pentagon of my prism. Now I need to multiply that times the height of this prism. This is where another set of very common mistakes happen. Oftentimes, people will multiply that times 18 because what does our common sense brain say? Our common sense brain says that the height of the barn is 18 because that's the height of the barn from the bottom to the top. However, the height of a prism defined in geometry is the distance between the two bases. So the distance between the two bases is actually 20 yards. That's the distance from one pentagon base to another pentagon base. So this height right here is not 18. That height right there is 20 yards. But we've been dealing in feet this whole time. So if we've been dealing in feet this whole time, I can't use yards as a linear measurement. I need to convert that into feet. I know that 1 yard equals 3 feet. So 20 yards equals, if I have 1 yard equals 3 feet, how did I get from yards to feet? I multiplied 1 times 3 is 3. So I'm going to multiply 20 times 3 is 60. 60 feet is what my height is of my prism. And when I multiply those two together, I get 9,975, which is B. Now, I looked at the clock before we started this problem. We started this problem at 6:07. It is 6:15. Now, did I take a couple of rabbit trails? Yes. However, that took us 8 minutes to solve that problem. And if I did it independently, it would still take a long time because there's so many steps. So I want you to consider that when you're going through these problems. If you are not proficient with a problem like this is not a low-hanging fruit problem, as Dr. A likes to say. This is a problem that even if you know how to do it, is going to take you quite a bit of time. So it might be a problem you want to save for the end just because of the depth that this problem takes you. All right, there's the answer for that problem in the GK course, but it's a great problem for everybody because everybody in the room needs to know how to find area of a triangle. Everybody in the room needs to know how to find area of a rectangle, and everybody in the room needs to know how to find area of a composed shape, which is two shapes put together. Everybody needs to understand basic components of volume as well. So it's a great problem for everybody. All right, let's move on to problem 2. Which of the following describes the relationship between these two lines? So how do we decide what a relationship is between two lines? Well, I'm going to use my answer choices to help me because that way I know what they're asking me to do. So they could be perpendicular, parallel, intersecting but not perpendicular, or coinciding. So that said, I know I'm trying to figure out if these lines are perpendicular, which means they intersect at a 90-degree angle or a right angle. Parallel, which means they do not intersect. Intersecting but not perpendicular is just that. They literally intersect, but they're not perpendicular. And coinciding means they are the same exact line. Now, what does that mean for how we're going to interpret this? Great question. This means that we need to find the slope of the line. Let's talk about that. So when we look at lines, let's say I have a line that goes like this, and I have a line that goes like this. How do I figure out if these are 90-degree or not? Because I use the slope of each of those lines. So perpendicular lines, Gary's absolutely correct, have negative reciprocal slopes. Parallel lines have the same exact slope. Intersecting but not perpendicular have anything but those two slopes. And coinciding have the same slope and the same y-intercept. Parallel lines will not have the same slope and the same y-intercept. Parallel lines will have different y-intercepts. So if we look at these two parallel lines, they have the same slope, but they have two different y-intercepts. Coinciding lines would be like there's one line and then here's another line. They're the exact same line. So that said, I need to figure out what the slope of these lines is to be able to figure out if these are perpendicular, parallel, intersecting, all of that. So how do I find out the slope? Well, I'm going to put it into slope intercept form. Slope intercept form, is y equals mx plus b, where m is your slope and b is your y-intercept. Following? So if I can get it into that format, then we're golden, because then I can easily see the slopes of each of the lines and we can quickly determine if we've got parallel, perpendicular, coinciding, all of that. Caroline, I saw your comment and I totally forgot to upload them into Dropbox again because I just forget. So I'm doing that right now, and then I'll post the links so that you guys can print them. All right, so to put it into y equals mx plus b form, I have to get y by itself. So I'm going to do some equation manipulation. So I have negative 2x plus 3y equals 8. The goal is to get y by itself. So I'm going to add the 2x to both sides because right now the 2x is negative. It's being subtracted. So I'm going to add 2x to both sides, and I get 3y equals 2x plus 8. Divide everything by 3, and we get y equals 2/3 x plus 8/3. That 8/3 in this moment right now doesn't matter. The 2/3 is really all that matters for right now. Then I am going to do the same thing for this equation. So I have 4x minus 2y equals 7. I'm going to subtract 4x in this case because the 4x is positive. So by subtracting 4x, I get negative 2y equals negative 4x plus 7. Why did I not write 7 minus 4x? Just because this is the format we're trying to get it into, and it just makes it easier to follow. Divide everything by negative 2. And I get y equals positive 2x minus 7/2. If you have any questions about how I'm solving this, please let me know. Now, when I look at the slopes, remember, the slope is the piece that's attached to that x. So the slope of this line is positive 2, and the slope of this line is 2/3 x. So are they the same? No, they're not the same. Are they the same? No. So I know it's not parallel because they don't have the same slope. I know it's not coinciding because they still don't have the same slope. Are they perpendicular? No, they are not negative reciprocals. If they were, this one would be 2/3 and this one would be negative 3/2. Or this one would be 2 and this one would be negative 1/2. So these lines are just intersecting and not perpendicular. All right, I'm going to post the link for tonight's slides down below here. Thank you, Joseph, for that reminder. I will get that while we're working today. So June 23rd, 22nd, problems. Here's the link. It says June 23rd because I got my dates confused, but this is the June 22nd link. I will get the other 2 weeks to you as well. All right, any questions about perpendicular, parallel, intersecting, all of that? All right, let's keep going. Oh, this one is fun. Okay, this is for my 6 through 12 people. High school people, 6 through 12, 7 through 12, any of that. So find the slope of the line tangent to the vertex of y equals 2x squared plus 8x minus 1. Find the slope of the line tangent to the vertex of y equals 2x squared plus 8x minus 1. All right, I want us to think about what this creates. We know that this, if we're taking that high school exam, we should know this is a quadratic because we immediately see this x squared, which tells me it has the potential to cross the x-axis up to 2 times. Does it have to? No, it doesn't have to, but that's another problem for another day. It has the potential to cross 2 times, which means it's a quadratic. So let's just sketch what a quadratic could look like. A quadratic could look like this. It could look like this. It could look like this. It could look a lot of ways. So I'm just going to, I know it's a positive quadratic because this number, that front coefficient is positive. So it's an upward facing parabola. Is this the parabola? No, I'm just sketching it. The slope of the line tangent. So we know how to find slope. We just talked about that. Slope is rise over run. I cannot put this into y equals mx plus b form because that is only for linear functions. So Slope is rise over run, or y minus y over x minus x. Now, tangent means touches at exactly 1 point. Now, to find the slope of the line tangent to a point, oftentimes we have to find the derivative to be able to figure that out. So this becomes a calculus problem very quickly. However, I want you to think about this before we just jump into doing the derivative. Where's the vertex on a parabola? In this case, it's right here, right? And I'm actually going to use a different color. In this case, it's right here. The vertex is the very lowest point of a parabola or the very highest point of a parabola, and it is symmetrical from there. If I draw a line tangent to this parabola at that point, what is the slope of that line? 0. Think about it conceptually. Before you jump into doing everything you know to do with these problems, this looks like such a complicated problem. Before you start doing that, think about where that parabola is and where a vertex is on a parabola. It's going to create a straight line with a slope of 0. Now, Gary asked a great question. How do we find the vertex? Well, let's talk about that. I found myself pointing to the screen. I love that. Yes, we're like little kids watching like a cartoon, and they're like, clap at the screen. Everybody clap 2 times, and it'll make the ball appear. And we're all doing that. Yes, when I'm asking you where the vertex is, I love that you're pointing at the screen. You're like, it's right there. It's right there. Trust me, I wish I could see y'all. I wish we were in the same room because it would make this so much more fun for everybody. So, vertex is in the corner. Okay, I love that you said that. In a shape that is closed, a vertex is in the corner. You're absolutely right. So this is a super rabbit trail, but this makes this problem available for everybody. If I have a rectangle, yes, that is a vertex. That is a vertex. That is a vertex. That is a vertex. If I have an octagon, all of those corners are vertex. However, in a parabola, there is no hard corner. It doesn't create a 90-degree angle. So it's the lowest or the highest point on that shape. Okay, going back to how do we find the vertex? To find the vertex in a shape that is not in vertex form, we do negative b divided by 2a, and that gives you the x value. So negative b is negative 8 divided by 2a is 2. So negative 8 divided by 4 equals negative 2. So the x value of your vertex is negative 2. The y value would be, we would plug that in to here to find the y value, but none of that is necessary to solve this problem. If we go back to the original problem, none of that is necessary to find the slope of a tangent line. You know the axis of symmetry. So yeah, in a parabola, we also have an axis of symmetry. So if I were to draw the axis of symmetry right through this parabola, you still, okay, so you could argue that that creates a corner, but you still have a curved line. You know what I mean? But if you draw a line tangent to the parabola, then it creates a corner. But that's, yeah, yes, you are correct. I'll just go there. All right, let's go ahead and move on. Now, I am skipping around just to be able to touch on a lot of other things. So if you've already downloaded that PDF, I am not going in order tonight. And the questions we don't get to tonight, I will add to next week. This parabola is an even function, correct? I love all the questions tonight. Yes, any parabola is an even function because it has the potential to cross twice. An odd function would be a cubic function or a fifth function. All right, this is more for my elementary K through 3 people. However, middle school and high school people always need to know the content that I'm going over in K through 3 or elementary, because you eventually have to apply that information. So, which of the following shapes has equal angles? Parallelogram, rhombus, rectangle, or trapezoid? So, let's talk about a quick definition of each of these. A parallelogram, and this really should say which of the following shapes has to have, not just has, because the parallelogram has the potential to have equal angles, but it doesn't have to have equal angles, if that makes sense. So a parallelogram, by definition, has 4 sides and has 2 sets of congruent parallel lines. Now, a rectangle has all of that as well. A rectangle has 4 sides. It has 2 sets of congruent parallel lines. But what differentiates a rectangle and a parallelogram is a rectangle has 90-degree angles or right angles. Oh, that says rhombus, lordy. So let's go ahead and move that down to rectangle, not rhombus. Glad I caught that. Okay. A rhombus has 4 sides. It also has 2 sets of congruent parallel lines. But what makes a rhombus different is it has 4 congruent sides, which means that all the sides are equal. That does not mean it's a square. I'm going to show you an example in a minute. And a trapezoid has 4 sides and has at least 1 pair of parallel lines. Now, this definition is up for debate. The new set of Florida standards, the best standards, that is the definition of a trapezoid. The old definition was that it had exactly 1 pair of parallel lines. I do not know how TExES and the Praxis define a trapezoid, but that's definitely something you want to know if you have to classify quadrilaterals, because a trapezoid is up for debate whether it has exactly 1 pair of parallel lines or at least 1 pair of parallel lines. So let's go ahead and draw what these could look like. Let's draw what these could look like. So a parallelogram, like the classic parallelogram, looks like this. It looks like a pushed over rectangle. Now, is a rectangle a parallelogram? Yes, a rectangle is a parallelogram. So because a rectangle has 4 sides and it has 2 sets of congruent parallel lines, it's a parallelogram. Is a parallelogram always a rectangle? No, because a parallelogram can be pushed over. A rectangle looks like this with those 90-degree angles. A rhombus looks like a pushed over square, but a rhombus could also be a square. And then a trapezoid could look like this. It could look like this, where these sides are parallel. However, if your standards define a trapezoid as at least 1 pair of parallel lines, then all of these could be defined as trapezoids. That said, which of these has equal angles? The only one that has to have equal angles is a rectangle. It has to have all 90-degree angles. The others do not have to have that. They have the potential to do that. I just had someone ask me, what is the definition of a kite? A kite has 4 sides. It has 2 pairs of equal sides that are adjacent to each other, which means they are next to each other. Okay, so a kite looks like this, and this side is congruent to this side, and this side is congruent to this side, and they're next to each other. Excellent question. All right, so we've done problem 6. Let's keep moving. I'm actually going to go over this one because this one was a question straight from our Facebook group. This problem comes straight out of our, I think it's our TExES 4 through 8 exam course, but this is good for anybody, middle school and high school. So, and in that course, there's no video for this problem, which I don't know why, but there isn't. So here's your video. A 7th grade math class is working with similar figures. The 2 right cones shown below are similar. Mr. Smith told the class that the surface area of the cones are 180 and 320 square units, and that the volume of the smaller cone is 120 cubic units. He challenged his class to find the volume of the bigger cone. What is the volume of the bigger cone? The most common mistake people are going to make when they deal with similar figures in this situation, and everybody's going to need to know this to some capacity, so I'll break that down, is they're going to go, the smaller cone is 180, and the smaller cone has a volume of 120, and then the bigger cone has a surface area of 320x. They're going to cross multiply, and they're going to call it a day. Unfortunately, you cannot do that because square units and cubic units do not mesh well in a proportion like this. It doesn't balance itself out the right way, and it creates a proportion that is not correct mathematically. So you cannot, in a proportion, put units that are not the same. You can't put squared units and cubic units. You can't put linear units and squared units. Similar figures are something that we see across the board, but you have to understand how similar figures relationships react. If I gave you something like this and said these rectangles are similar. This side is 3 and this side is 8. I know that doesn't make sense. I didn't draw them accurately. Don't jump down my throat. This side is 12. What is this? In that case, you could do 3 over 8 equals 12 over x because these are all linear measurements. However, we're not dealing with only linear measurements. So let's go ahead and talk about how to solve this problem. So the smaller cone has a surface area of 180 and a volume of 151. Did I mess this problem up? Hold, please. I just realized that I think the volume of the smaller cone is 151. Give me 1 second. I'm going to pull it up on Facebook. Or if someone has the problem pulled up in front of them from our Facebook page, let me know. Because I don't think that that's the correct measurement, which means we're going to have the wrong answer choices if I had a typo. So I'm going to pull this problem up. I'm going to put a pause on this problem right now. And once I get it pulled up, we'll come back to it because I want to make sure that I have the correct volume. And I think that that's the wrong volume from the problem that we're talking about. So let's go ahead and just skip to this problem and then we'll come back to it. All right. This problem is a problem that someone on Facebook asked me to solve a similar one However, I'm not sure where this problem is from. And so for copyright reasons, I did not want to solve that exact problem. So I came up with a problem very similar to it. And then you all can go to our Learning Liaisons Customer Hub, find the problem that's just like this in our Customer Hub, and then you can go and practice and solve one on your own. So this problem says, the table below shows Sarah's class schedule for a week. On Tuesday, what fraction of the day from 8 o'clock to 2:45 is she scheduled to be in class? So we see that on Monday through Friday, she's got different classes. And these are the time blocks that she's in class. However, what I want you to notice is that these time blocks do not back up to each other. They have gaps in the day. So the total amount of day that we have does not equal this plus this plus this plus this plus this plus this, because there's gaps in the day and that time counts. So we have to make sure that we're accounting for all of that time. That's going to be one of the mistakes that people make, is that when they look for the fraction of the day that they're calculating, you have to make sure that you're not just adding 55 plus 55 plus 55 plus 55 plus 45 plus an hour and 40, because you have to account for those gaps. So we know we're going from 8 o'clock to 2:40. So because of that, I know I'm going 6 hours and 40 minutes. How do I know that? Well, from 8 o'clock to 9 o'clock is 1 hour. 9 to 10, 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 2:40. So my total amount of time is 6 hours and 40 minutes. Joseph and Gary, you are my lifesavers because my computer is acting so slow right now and I could not pull up that problem. So thank you. We will go back to that problem and do the 151. I knew I made a mistake. All right. So 6 hours and 40 minutes. Now, I can't put that on the bottom of my fraction. So I'm going to recalculate that into minutes only. So 6 hours, I know that in 1 hour, I have 60 minutes. So I'm going to multiply 6 times 60. That gives me 360. I'm going to add the extra 40 minutes from this 1 hour and 40 minute time block, and that gives me a total of 400 minutes. So my denominator, or my total value, is 400 minutes. In a fraction, we have to make sure that we know what we're dealing with. So when I'm trying to find the fraction of the day, what I'm really doing is I'm trying to find a part over a whole. That's all a fraction is, a part over a whole. The whole day is 1 hour, or 6 hours and 40 minutes, which is really 400 hours. So we have, and I realized I made an edit to this and didn't change that. So now I need to figure out what fraction Sarah is in class. Well, she's in class on Tuesday for that time block, that time block, that time block, and that time block on Tuesday, because we're only looking at Tuesday. So she has a 55-minute time block here, 55-minute time block here, 45-minute time block here, and 1 hour and 40 minutes, which is 60 plus 40, which is 100 minutes. So I'm going to add all of those time blocks together and put it on the top of my fraction, because that's the part of the day that we're dealing with. So 55 plus 55 plus 45 plus 100. I'm going to use my handy dandy calculator to solve that. $55 plus 55 plus 45 plus 100 equals 255. So we have 255 over 400. 255 divided by 5 is 51. And I just realized I changed this problem again, and I made this a 40-minute time block when I was creating this problem. And so this should be 40, this should be 40, and that should be. Okay, so we're going to erase all of these answer choices because I did not edit this problem. So we're going to go. Whoop, 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 whoop. So that said, I will fix this. We've got 255 over 400. To simplify this, I'm going to divide each of them by 5. 255 divided by 5 equals 51. And 400 divided by 5 equals 80. So my fraction of my day that I'm spending in class is 51 over 80. As I was solving this, I was like changing numbers in my head to make it like make more sense. And then I never changed them on the chart. So when you're solving a problem like this, you want to make sure that you're taking the fraction of the part over the whole. That said, you have to make sure that you realize that we've got these little tiny 5-minute breaks in between, which is going to totally change your answer if you don't recognize that. All right, let's go back to this and let's talk about using 151 instead of 120. So the volume of the smaller cone is 151 cubic units. He challenged the class to find the volume of the bigger cone. So the surface area of the bigger cone is 320 and the volume is question mark. Now, in order to find the ratio, the similar ratio of these two, we have to recognize something. We have to recognize that ratios or proportions operate under a linear measurement. So with that said, if I take this information I've been given and I think about that ratio, let's go ahead and put the surface areas over each other. So if I take the larger surface area and put it over the smaller surface area, big cone over small cone, and I simplify this, divide them both by 10, divide them both by 2, I get 16 over 9. Divide them both, can't divide them. That's the ratio of the surface areas. Now, that is also a perfect square. If I square root that, this also is the same thing as 4/3 squared. How come I did that? Because that right there is the linear proportion. This is the squared proportion. So because the units are squared, I can square root the proportion to find the linear proportion. I can then use that linear proportion, cube it, to find the volume of that bigger cone, because volume is in cubic function. So, or is in cubic units. So now if I put the volumes over each other, x over 151, and I set it equal to the proportion or the scaled ratio, I can set it equal to 4/3 cubed because that's the linear ratio. And if I cube it, that will give me the ratio of the volumes because I've now taken my linear ratio and I've cubed it. So 4 cubed is 64. So x over 151 equals 64. 3 cubed is 27. Now I can cross multiply. 27x equals 9,664. Divide both sides by 27. And I get x equals 357.9, which rounds up to 358. So when you're dealing with the difference between linear measurements, cubic measurements, squared measurements, you have to realize that they do not create proportions that play well together. And you either have to find the linear measurement and square it or cube it, or you have to just know that you can't just put them over each other. You can't put the length of a side over the area of a rectangle in similar figures. You have to find those ratios. All righty. Amy rents a table at a fair, for which she is charged a $10 daily rental fee. She purchases apples from a farmer. Oh, yes, I absolutely can. There you go. She purchases apples from a farmer for 60 cents each, $60 each. That would be a really expensive apple, and sells them at her table for $1 each. If she expects to make a total profit of at least $50 for the day, what is the least number of apples she must sell? So let's just conceptually talk about this. So she's charged $10. And she purchases apples. So these are like her expenses. And she purchases apples for 60 cents each. X being the number of apples she purchases. And then she sells them for $1 each. So her profits are, or really I should say the amount of money she's bringing in, really. So the amount of money she's bringing in, money brought in, is $1 times the number of apples she sells. If she expects to make a profit of $50, now profit is the amount of money that she gets to take home. So we have to take what she makes and then subtract the $10 and subtract the 60 cents that she had to pay per apple. So on each apple, how much is she profiting? On each apple, she's profiting 40 cents per apple because she's selling them for $1 and then she's buying them for 60 cents. So let's just use our answer choices to help us here. If she sells 90 apples, that means she made 40 cents times X. So 90 times 40 cents equals, use my calculator here, 90 times 40 cents, she made $36. And that still doesn't include the fact that she had to pay $10, which equals she only made $26. So that definitely does not equal $50 in profit. So that's way off. Because that's so far off, I'm going to jump all the way to letter D. Because if I only increase by 10 more apples, that's not really going to benefit me. So if I multiply 150 times 40 cents, that gives me $60. Subtract the $10 fee that she had to have, and look at that. We've hit $50 and my iPad just disconnected. So we're going to reconnect it. So you notice that's a test-taking strategy. Because my answer in the first, when I used my answer choices in the first letter, A, was so far off, I went ahead and skipped all the way down to D because I knew if I went B, C, D, I wasn't going to get anywhere very quickly. So by skipping to D and getting a number that was bigger than 50, I would have tried C because we were looking for the least number of apples that she must sell, not just any amount of apples. All right, how did I get the 6 hours and 40 minutes? Because I knew I was operating from 8 o'clock to 2:40. So from 8 to 9 to 10 to 11 to 12 to 1 to 2 o'clock is 6 hours. And then from 2 to 2:40 is 40 minutes. If you added 55 plus 55 plus 55 plus 55 plus 45 plus an hour and 40, you would not get 400 minutes. But you're also not accounting for those 5-minute breaks that she has in the day, and that counts as part of her day. So you have to account for all of that. All right, like I told you before, I skipped around, and that document that I gave you, I did not solve all the problems. Whatever problems we didn't solve today, I will solve next Wednesday. So I've got slope of a line tangent to a different point other than the vertex for next week. I have parallel sides. We have finding the center and radius of a circle when it's not in standard form. We have putting something into vertex form. So those are all problems for next week. If there is something else that you want to see me solve next week, please let me know in the comment box or find me on Facebook, Amy Sink. I love including problems that you guys are struggling with because that's how you learn. So if there's anything else you want to see me solve next week, drop it in the comment box and let me know. Otherwise, I will see you all next week. Thank you so much for all of the questions that you asked me. Gary, I will talk about diagonals bisecting next week in a problem because that's definitely a common question that I get. So we will talk about that next week as well. So without further ado, I'm going to turn it back over to Dr. A for a quick closing message, and I will see you all next week. Don't forget to comment or let me know on Facebook what you want to see me go over next week.
All
Bye,
right,
guys.
so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.